Ancova. Okay, I'm going to walk you through this ancova. So a statistics teacher wants to see if there's any differences in entrance exam scores based on gender, male or female, or between the amount of pre-college preparation, 3 levels, none, less than 2 years, greater than 2 years, that each student has had. So those are your IVs, right? Sex, either male or female, and pre-college preparation. Those are your IVs. Your DV is your entrance exam. So if this is an ANCOVA, you're going to run it just like a two-way ANOVA or a factorial ANOVA. So we're going to run the factorial ANOVA, and we're going to check to see if either GPA or age was a covariate. Let's go. We're going to go to Analyze, General Linear Model Univariato, Mr. Roboto. So exam scores, there we are, that's our DV. And then preparation and sex and what were our covariates? I already forgot. It was age, GPA. Remember, the software will tell us if either one of these is in fact a covariate or not. So let's click some buttons over here. No. Yeah, it doesn't hurt. So we're going to do these, and if they cross, that means there's interaction going on. Yeah, we always do our options. And that's it. So first step, hold on, let me arrange this thing. So first step, let's check to see if age and or GPA were in fact a covariate. So there's age and there's GPA. So we're going to go to the significant value. And age definitely was a covariate. GPA, no. Okay, so GPA was not a covariate. So I'm going to rerun this bad boy and simply use age, and we'll go by those results. So with age identified as a covariate, let's go to town. We're going to go to Analyze, General Linear Model Univariate. Everything should be the same. I'm simply going to kick out GPA. You, go find someplace else. And click OK. Now we're going to get to the nitty gritty. So here are the results. This is how many were in each group. These are your means. Here's your Levine's test that says it did not violate the assumption of homogeneity variance. Thank you, Captain Levine. Moving on. So this is the text box. This is your between group Anova source of variance box. And you'll notice that I reran it without putting GPA in as a covariate test. And the numbers changed slightly. So if you left it in there, don't worry about it because the actual results don't change at all. Just the numbers change by a couple of thousand. So I'm just going to, again, I reran this ANCOVA, but I pulled out the GPA because it was not a significant covariate. But let's see what this means. So age was a covariate. Yes. Main effective preparation, yes. In other words, significant difference in exam scores depending on how much preparation these guys had. And there's a borderline significance for sex. So in other words, there was barely a significant difference on the exam scores between the males and the females. That's all that means. And there is a significant preparation and sex interaction, which means that again, if there was a difference between the males and the females and or between how prepared they were, that means, again, that there's some kind of interaction going on. Either the males did better or the females did better or they did worse, that kind of thing. So, but what I'm going to do is I'm going to look at the effect size. So the effect size, right off the bat, preparation is the main reason why the scores are different. I'll say that again. Preparation, look at this effect size. We can explain 75% of the variance of exam scores based on how well they were prepped. When you look at the sex thing, it's only about 12%, 13%. You can blame that on gender difference, which is minor, right? This is barely significant, okay? But there was an interaction. And hold on, let me get this crossing graph means going for you. And there's the graph that shows that they are interacting between preparation and sex here. So in a nutshell, you're going to write it up like this. Hold on. A two-way ancova was run to analyze the variance in entrance exams based on male or female or the amount of college prep they had, right? And then you're going to check to see if age and or GPAs was acting as a covariate. So first of all, the data did not violate normality, nor did it violate the homogeneity variance. And it indicated that age was indeed a covariate. There's the numbers. And the GPA was not a covariate. There's the numbers for that too. So after controlling for age, actually, I reran the data, but I pulled out GPA as a possible covariate. So the numbers are going to be a little bit different if you left it in. Again, don't worry about it if you did. So after controlling for age, right, that's what you do with covariates. You control for them, and then you rerun your Anova, and that will only make your results stronger, more believable. Okay, so there was an omnibus F that shows there's a significant difference between either the males or the females or the different levels of college prep. And that was huge, right? It's 142. Effect size was about 97%, unheard of. And then you look at the main effects for each of the IV, and there was one for preparation, and there's all that stuff. And I put the effect size in there, which means that, again, it's obviously their preparation that's causing the significant differences between the means. That's what's going on. And then just barely there's a difference between males and females. In fact, this is so small, it could have just happened by chance. All right, and then there was also a significant interaction between prep time and gender-based. So, and again, it's prep time. That's your main indicator of how well these guys are going to do. And it suggests right off the bat that the people that have had less than 2 years did the worst. And the people that did the best were the males that had more than 2 years. They did the best. So I'll say it again. Males with less than 2 years of prep did the worst. Males with more than 2 years prep did the best. And that's about it. I hope this helps. MGZ out.